Exponential equations, it is the topic that I'm going to discuss in this video or the next one. I don't know. It depends upon the length. Exponential equations, the definition of that is that an exponential equation is an equation which the unknown occurs as part of the index or exponent. For example, we have a raised to x is equal to b. The unknown occurs as part of the index or exponent. So the x should be in the exponent. Okay, for example, we have 2 raised to x is equal to 8. So our a is 2, this is our a, this is our unknown, and this is our b, like that. So how to solve that? You need to solve this by, if you cannot solve it in the simplest way, then you need to solve it by logarithm. That is the next series of video that I'm going to discuss after exponential. But this one, if you can simplify the b so that it has the same base as your a, then it will be alright to solve. For example, 8 is 2 raised to 3. So if you can find that, then if they have the same base, then you can equate the equation x is equal to 3. How do we know that? Because 2 raised to 3 is equal to 2 raised to 3. That is 8 is equal to 8. So when the left-hand side of the equation and the right-hand side of the equation are equal, then x is the right solution. 3 is the right solution. And then we have also 3 raised to x is equal to 81, for example. Then we know that 3 raised to x is equal to 3 raised to 4. That is 81, because 3 times 3 times 3 times 3, this is 9, and this is 9. So 9 times 9 is 81. So you have the same base now. So we have x is equal to 4. To summarize, if the base numbers are the same, that means you have the same a there, you can equate the exponent as we did here. So the bases are the same, we can equate the exponents. Okay, let's see if we can find some example here. Solve for x. So we have, for a, we have 2 raised to x is equal to 16 is 2 raised to 4. Because 2 times 2 times 2 is 8 times 2 is 16. So we have x is equal to 4. For b, we have 3 raised to x plus 2 is equal to 1. 27 is 3 raised to 3, because 3 times 3 times 3 is 27. And then and this one, we have 3 raised to x plus 2. One law in the laws of exponents says that this will become negative exponent, 3 raised to negative 3. Now we have the same base. X plus 2, the exponent, we can equate the exponent is equal to negative 3. So we have minus 2 there, minus 2. So it should be x is equal to negative 5. You can control that. You can check it if it's correct. So we have 3 raised to negative 5 plus 2 is equal to, it should be 3 raised to negative 3. As you can see already that it is correct. Let's see if we have more example. This one. So we have 4 raised to x is equal to 8. we know that 8 is 2 raised to 3. Sorry. I'll remove that. Raised to 3. So we need to transform 4 so that base will be 2. So we have 2 raised to 2 is 4 raised to x. And then we have a law says that 2 raised to 2x, we multiply the exponent, is equal to 2 raised to 3. Now we know that we have the same base, so we have 2x is equal to 3. Divide both sides of the equation by 2. Then we have x is equal to 3/2 or 1.5 if you want to express that in decimal. But it is better to express. You can check it if it's correct. I will check it later. B, we have 9. 9 is the same as 3 raised to 2 raised to x minus 2 is equal to 1/3 is the same as 1 divided by 3 raised to 1. Okay, so we have 3 raised to, we multiply 2 times x minus 2 is equal to 3 raised to negative 1. Now we're ready. We have, if we multiply, we write here 2 times x minus 2, even in parentheses, is equal to negative 1. We have the same base already. Either you multiply or you divide. It doesn't matter. I will show you both. I will divide first. That is 2x minus 2 minus 4 is equal to negative 1. Plus 4 there, plus 4. Then this is 2x is equal to 3. And then divided by 2 again, divided by 2. Then we have x is equal to 3/2. The same there. Can we do that with another solution? Yeah. 2x minus 2, 2 times x minus 2 in a parenthesis is equal to negative 1. If I will divide both sides of the equation by 2 already, then I have x minus 2 is equal to negative 1/2 plus 2 plus 2. Then we have x is equal to, if I will expand this by 2, and I have 4 minus 1 is 3/2. So it depends what you want to do. Can we check if they are the same? So if I have 9 raised to 3/2 minus 2 is equal to 1/3. So this is now 9 raised to, this is 4, 2. So we have negative 1/2 is equal to 1/3. If we put that as as a denominator, then we have 1 raised to 9. 1 divided by 9 raised to 1/2 is equal to 1/3. And as we said before, 1/2, 1/2, a number raised to 1/2, it is the same as square root of that number. So square root of 9 is 3. So we have 1/3 is equal to 1/3. And here, if I can take another, so that another color. So if we have 4 raised to 3/2 is equal to 8. So if I have 4 raised to 1/2 raised to 3, is that equal to 8? Yeah, I can put question mark there. It's the same here also. I usually put question mark to ask if they are equal. And then the square root of 4, because 4 raised to 1/2 is the same as square root of 4, then we have 2 raised to 3. And that is equal to 8. So 8 is equal to 8. So they are correct. Let's see if we have more. Solve for x. I think I need to do this in my next video. It's already 10 minutes. So, hang on.